Hello, this is Chaudhry Mahmood Anwar. Thank you for reaching out. Today I'm going to brief you how to analyze a basic path model and how to incorporate control variables into a path model you will construct in PLS by using SmartPLS software. This was the new project I have created in my last lecture. I will use the same project, and the framework I will analyze is look here, satisfaction with the implementation of technology and adoption of green IT. We will analyze the impact of these two variables on student loyalty. I will not use the trust in this example because I'm going to incorporate control variable into the model. This would be our basic model. So here is the smart PLS. Click on new project. New project indicators have been loaded. You can see here. Okay, I will draw the model now. GIT mean green information technology, and this is satisfaction. For indicators, green IT 3 indicators, and these two are the exogenous variables, and loyalty with 3 indicators is the endogenous variable. Okay, so I'm going to analyze this path model. First, I will rename it GIT. Okay, SAT. Okay, LOY. Okay, now I'll connect the exogenous variables to endogenous variable. Connect. You will see if it's connected properly, the model variables become blue. This indicates that the model is well constructed. Now calculate, go to Bootstrapping. We'll use 500 subsamples. Click on do parallel processing, amount of results, basic bootstrapping. So you can change to complete bootstrapping as well. It will take more time to process. Advanced settings, select bias, corrected and accelerated bootstraps. Test type would be two-tailed. Always use two-tailed test to reduce the probability of type 3 error. The significance of the test level is at 0.05. PLS use path model because this is a path model. We don't need any weighting here. Start calculation. So here's the model. You can see that the model, you can see that the impact of both variables is significant on the endogenous variable, and both variables are explaining 35.4% of the variance. The impact of GIT on LOI, the t-value is 2.012, and for satisfaction on loyalty, the t-value is 7.010. So both exogenous variables have a significant impact on loyalty. These indicators or various statistics available here are also very important. You can use the p-values. These are the p-values. You can use path coefficient and p-values. The path coefficient for this relationship is 0.144, and for this relationship is 0.532, and the significance at 0.001. Path coefficients and t-values, you can use the combination of path coefficients and t-values, and you can also see t-values alone. This is for inner model. For outer model, you can select outer weights or loadings and p-values. You can see. You can also select outer weights and loadings and t-values, and p-values only and t-values only. Okay, so most important are loadings, so you need to select the loadings. For construct, you can see the AVE, average variance extracted. The AVE value for GIT is 0.64, for SAT is 0.51, and for loyalty is 0.75. All AVE values are greater than 0.50. Therefore, the AVE values are acceptable. Second is composite reliability. The composite reliability for GIT is 0.84, for SAT is 0.81, and for loyalty is 0.90. Therefore, these are in acceptable range because it's above 0.70. You can also check on back alpha. Alpha value for GIT is 0.71, for satisfaction is 0.69, and for loyalty is 0.83. So all the alpha values are in acceptable range because they are greater than 0.60 or 0.70. R square is also important. Both exogenous variables explain 0.354 mean 35.4% of the variance in endogenous variable. This is the adjusted R square, which is 34.1%. And this is row A. Well, row A is also a reliability statistics, but is underdeveloped. So you will not use row A. You will only rely on AVE, composite reliability, and Cronbach alpha. If you want to see which path has more strength, then you can select use absolute values. You can see that the thickness of the regression lines is increased based on the value of their path coefficient. Okay, you can see this is actually 0.144 path coefficient, so the line is thin, and here the path coefficient is 0.532, so the line is quite thick. So this is how you will check various statistics available here in calculation results. These are the indicators. Now I will incorporate a control variable into the model. Select. Okay. I will incorporate gender because I want to see whether gender has any confounding impact on the endogenous variable loyalty. I will again connect the regression lines. Exo to endo, and I will rename it gender. Okay, now I'll connect the regression lines from exo to endo. Here I will connect gender to loyalty. The model variables turn blue, therefore we will conclude that now model is correctly connected. Go to calculate, bootstrapping. Again, the similar settings I have already explained. Start calculation. So this is our new model. Path coefficients and p-values. If you make it blank, then all will be gone. We will use outer values. You can use outer weights. Okay, now we will not concentrate on this. Let's see that the path coefficient for the impact of GIT on LOI is 0.14, and the impact of satisfaction on loyalty path coefficient is 0.582. But the impact of gender on loyalty is insignificant. The coefficient value is negative 0.154, and the p-value is 0.059, which is greater than 0.05. Therefore, we will conclude that gender has no significant impact on loyalty. Here you can see the bootstrapping window, the gender. This is gender to loyalty. The impact is insignificant. And for these two relationships, the impact is significant. These are the confidence intervals. For gender to loyalty, the impact is significant. For GIT to LOY, 0 does not lie within this confidence interval. Therefore, the impact is significant. And for satisfaction to loyalty, 0 does not lie within this confidence interval. Therefore, the impact of satisfaction on loyalty is significant. This is how you will analyze your basic PLS path model in SmartPLS, and you can easily incorporate control variables into your model. Most often, I have got requests from my viewers, my students, that how we can incorporate the control variables into a PLS model and how we will interpret. So this is how you will conduct this type of analysis with the inclusion of control variables. Thank you very much for attending this lecture.